Hi all, in this video I am going to explain 50 multiple choice question and answers in control system. So don't skip the video. Question number 1. Transfer function of a simple RC integrated circuit is shown in figure is given by R and C is given. This is the simple RC network. I am going to find out the transfer function. Here Vi of S and V naught of S. V naught of S divided by Vi of S equal to 1 by Cs divided by R plus 1 by Cs. 1 by Cs divided by RCS plus 1 divided by Cs. Both Cs get cancelled. 1 by RCS plus 1. What is A? A is 1 by RC. 1 divided by 1 by A in the S plus 1. The answer is A by S plus A. Option D is the correct answer. Problem number 2. Transfer function of simple differentiator circuit is shown in figure. Capacitance and resistance connected in series combination. Here the input is Vi of S, output V naught of S. I am going to find out the transfer function, that is V naught of S divided by Vi of S, that is equal to R divided by R plus 1 by Cs, that is equal to R divided by RCS plus 1 divided by Cs. RCS plus RCS plus 1. 1 by RC equal to A. Put the value S by A divided by S by A plus 1. S by A divided by S plus A by A. Both A get cancelled. The answer is S divided by S plus A. Option B is the correct answer. Next problem. Laplace transform of t power n plus 1. So what is the formula? Laplace transform of t power n plus 1, that is equal to n plus 1 factorial divided by s power n plus 1 plus 1. So the answer is n plus 1 factorial divided by s power n plus 2. Option A is the correct answer. Next problem. Laplace transform of integral of f of t is. The integral of f of t 0 to t, the Laplace transform. The answer is f of s divided by s. Option A is correct. According to the initial value theorem, the initial value f of 0 plus of a function f of t is given by. Initial value means f of 0 plus, that is limit t tends to 0 f of t. So this is the equation. I am going to convert this into Laplace. So 0 plus, that is equal to limit s tends to infinity. S into f of s is the correct answer. Option B is the correct answer. Next problem. Laplace transform of df by dt is. Derivative of f, df by dt, that is equal to s f of s minus f of 0 plus. That is the correct answer. A is the correct one. If f1 of s and f2 of s are the Laplace transformation of f1 of t and f2 of t respectively, then Laplace transform of a function a f1 of t plus b f1 of t will be. Here a f1 of t, what is the Laplace transformation? A f1 of s plus f2 of t, what is the Laplace transformation? f2 of s. So what is the answer? Answer is option A is the correct answer for this problem. So option A is the correct answer. Next, according to the final value theorem, the final value f of infinity of a function f of t is given by. So what is f of t? That is equal to limit t tends to infinity f of t. Convert this into frequency domain. F of infinity equal to limit s tends to 0. This will be 0 in s. S into f of s. So option C is the correct answer. Next problem. Laplace transformation of f of s of any time function f of t is given by. Any time function that is given by one-sided Laplace transformation f of s is 0 to infinity f of t into e power minus st into dt. That is the correct answer. Next problem. The transfer function c by r for the closed loop system shown in figure. Forward path g1 and g2 both are connected in series. Resultant is g1 into g2. Now this is in the forward path. I am going to find out the transfer function c of s divided by r of s is equal to g1 g2 divided by 1 plus g1 g2 into h1. Option B is the correct answer. Problem. The transfer function c by r for the closed loop system is. The forward path first. This is the negative feedback loop. First I have to reduce the negative feedback loop. G1 by 1 plus G1 H1. This block and G2 both are connected in series. Both are in the forward path. I have to reduce this G1 G2 divided by 1 plus G1 H1. The feedback loop we are having H1. Find C of S divided by R of S, that is G1 G2 divided by 1 plus G1 H1 the whole divided by 1 plus G1 G2 by 1 plus G1 H1 into H1. G1 G2 divided by 1 plus G1 H1, take LCM, 1 plus G1 H1 plus G1 G2 H1 divided by 1 plus G1 H1. Both are get cancelled. Finally, we get the answer B. Option B is the correct answer. Second, 12th problem. Area under a unit impulse function. So area under, this is the unit impulse function. Area is equal to unity. Problem. The transfer function is defined only for linear time invariant system. with all initial conditions are 0. That is Laplace transformation of output to the Laplace transformation of input. If the poles of a control system lie on the imaginary axis in the S-plane, the system will be marginally stable. D is the correct answer. Next problem. Some expressions related to impulse response is given below. Mark the correct expression. The correct is infinity to plus infinity del of t in dt equal to 1. That is the correct answer. Next, which of the following system is stable? Consider the first one. All are positive. This is the stable system. Here, s power 3 is missing. This is unstable system. Here the first column of the root array should be positive, but negative term comes. This is also unstable. Here we are having negative term, so this is also unstable system. The correct one is 16A. 17. A control system is stable when the answer is roots of the characteristic equation have positive real part. Wrong. Zeros of the system negative real part. Wrong. Impulse response approaches 0 when time tends to infinity. Wrong. D is the correct answer. 18. Roots of the characteristic equation are nothing but poles of the system. A is the correct poles of the system. One of the following methods can be used to determine the relative stability of the control system. That is root locus method. 20th problem. The first column of root table containing the following integers, the system is stable because all are positive. The column element in the root array should be positive, so we can say the system is stable. Next problem. The first column of truth table contains the following integers. The system is unstable because there should be two sign changes, one in the first column, one is positive to negative, negative to positive. So two roots are in the right half of the S-plane. So the system is unstable. Next problem. Truth tables are separately constructed for two control systems. The first column obtained where 1350 minus 1 for the system M, 23 minus 461 for system N. Both the systems are unstable. Negative real part is there. The first column of the root array should be positive. We can say that unstable system. But both are unstable system. But N is more unstable. There are two sign changes. Here one of the sign change, next sign change. Two sign changes in the N. So, but N is more unstable. Next problem, problem 23. Marginally stable system are also called as unstable system, have only one of poles lying in the RHS of S-plane, equal number of zeros and poles, none of this. Marginally stable are also called the unstable system is the correct answer. For the a feedback control system has transfer function is given by. It is the type 3 system because denominator pole at origin is 3. So this is the type 3 system. The position error constant of a type 1 canonical feedback system is given by 25. Option A is the correct answer. This is positional error constant Kp. Next, the transfer function of the system is given by 100 divided by a square plus 16s plus 100. First of all, here we are going to find out damping in a system. For finding out damping, first we should know what is the general transfer function of second order system. C of S divided by R of S is omega n square divided by S square plus 2 zeta omega n S plus omega n square. Now I am going to equate both the equations. Omega n square, that is 100. What is omega n? That is plus or minus 10. Have to take the plus value, radians per second. Next, compare the coefficient of S. 2 zeta omega n equal to 16. Now I am going to cut this. Zeta omega n is 8. What is zeta? 8 divided by 10. That is 0.8. This is the underdamped system. A is the correct answer. Underdamped system means damping ratio is less than 1. That is underdamped system. Next, the velocity error constant of a stable canonical feedback system is given by limit s tends to 0, s into g of s. This is the correct answer. So option B is the correct answer, kV. The acceleration error constant of a stable canonical feedback system is given by, the third one is correct, limit s tends to 0, s square into g of s. Next, what is the center of asymptotes for an open loop transfer function? That is centroid. What is center or centroid? That is summation of poles minus summation of zeros divided by number of poles minus number of zeros. How many poles here? 0, 0, minus 4. How many zeros? Zeros are minus 2 only. Have to substitute this. Minus 4 minus 0 minus 0 minus of minus 2 divided by number of poles 3, number of zeros 1. Minus 4 plus 2, that is minus 2 by 2, that is minus 1. Option A is the correct answer. Next, the open loop transfer function of a control system has 5 poles and 2 zeros. The poles are located at minus 3, minus 5, minus 7 with remaining 2 at the origin. The zeros are located at minus 1 and minus 6, the center of asymptotes. What is centroid or center of asymptote? Equal to centroid. Summation of poles minus summation of zeros divided by number of poles minus number of zeros. Okay, summation of poles minus 3 minus 5 minus 7, remaining 2 are 0, that is located at the origin, minus of minus 1. Then minus of minus 1, then minus of minus 6 divided by 5 minus 3. So 8, 7, 15, 15 plus 1, that is 14, 14 minus 14 plus 6, that is minus 8 divided by 2. Sorry, 5 minus 2 only, not 3, divided by 3 minus 2.66. That is the correct answer. Option B is correct. Next, number of asymptotes in root locus for the above system. The formula is number of poles minus number of zeros, number of poles 5, number of zeros 2, so total number of asymptotes that is 3. Option D is the correct answer. Next, what is the transfer function of the system? Having a gain factor of 9 and pole 0 map as shown in figure. Pole is 1, one of the 0 at the origin, remaining 3 poles are available. How to write this? K into S minus 0 divided by S plus 1 minus of minus 1, S minus of minus 2 plus 2 into S minus of minus 3, that is plus 3. What about K? K is given 9 S divided by S plus 1, S plus 2 and S plus 3. Option D is the correct answer. Next, the transfer function of the system 1000 by 1 plus 0.1s into 1 plus 0.01s. The corner frequencies are. How to find out the corner frequency? A plus JB. For example, I have to take this. How to find out A by B is the formula to find out the corner frequency. For the first one, 1 by 0.1, that is 10, corner frequency. Next, 1 by 0.01, that is 100. So, two corner frequencies are 10 and 100. Option C is the correct answer. The capacitance cannot be used to fabricate the lag network. That is wrong. It's a false statement because the capacitance can be used to fabricate a lag network. Next, the inductance is not being used to fabricate a lag network because the reason is it produces time delay and hysteresis loss. 36. Which of the following the source of nonlinearity? Backlash in gears, saturation, both are the sources of nonlinearity. Next, a system is critically damped. If the gain of the system is increased, the system will underdamp. It is the correct answer. Nyquist criteria gives direct value of corner frequency, that is B, false. Next question, which of the following characteristics can be attributed to ideal relay? 4 are given. Option A is the correct answer. The steady state response of a system is dependent on both applied input and system poles. That is the correct answer. 41. The lead lag compensation will improve both transient and steady state response. The lag compensation in the control system is achieved by adding zeros in the transfer function of the system. Next, the frequency domain analysis, both amplitude and phase varies with frequency change. Option A is the correct answer. Next, the damping factor of a system is unity. The system is critically damped. Option C is the correct answer. Next, the roots of the closed loop control system can be obtained from Bode plot. The option is false. Option B is correct. In open loop system, the control action dependent upon desired output, that is also false. If a bandwidth of the control system is increased, the noise in the system will be increased because bandwidth is directly proportional to noise. Option A is the correct answer. Then the settling time of the second order linear system is 4 times of time constant of a system. Option A is correct. Next, the Nyquist plot shown in figure indicates that it is an unstable system. That is a stable system. The transient response of the system cannot be determined from root locus analysis. The option is false because transient response of the system can be determined from the root locus analysis.